Okay, so after we got past this point, the way that you would say to prepare it is you would say, take, and you want to write this down because I'm not going to do very many of these. Take 20.0 milliliters of stock solution. What was the molarity of that stock solution? 2 molar, right? So take 20 milliliters of the stock solution and add to a volumetric flask. Okay, so volumetric flask. It's a flask, right? And it's going to actually have a specific volume designated for it. I have like a bunch of varieties. Somewhat female flask shaped, just a little bit, but they've got this long skinny neck. And then this has it's got this etched line right here. That exactly, if you fill up the water exactly to that line, it's exactly 250.00 milliliters. This 0.00 means how many sig figs is this volume to? 5. 250.00. So 25000. 5 sig figs is extremely accurate. These are probably like $20 per flask. So they're so expensive because they're very, very accurate. I have some little baby ones you guys can use today that are 50 milliliters. So they measure exactly to 50.00, which is 4 sig figs, which is really good. Beakers, they have 1 sig fig. They're horrible at measuring things. And our flask in the back, they're horrible at measuring things. They have 1 sig fig. What's better than those for measuring? Graduated cylinders and the graduated pipettes. So you would take 20 milliliters of the stock solution, which is the 2.0 molar solution, and add to a volumetric flask. Then fill up flask with water to the blank milliliter mark. What how many milliliters of this next solution that I want to make? How much? How many milliliters of it did I want to make? Yeah, we'll see. So I'm gonna go over here. It says you want to make 100 milliliters of that diluted solution. So I would want to fill it up to the 100.00 milliliter mark. So in this case, you wouldn't grab this graduated or this volumetric flask because this one is a 250. It fills up to 250. You would grab a smaller one that measured up to 100. So you just have to grab the appropriate one, and then invert to mix. That's how you prepare a solution. So what you would do is you would, for your solution, you would just pipe that in, your 20 milliliters, you fill it up with water to the etched mark, and if it was like salt water like we're going to make, I'm just going to put my hand on top like this and go invert. That's it. But if it's a true chemical, you put some like parafilm, which is like this sticky stuff on top, or a quart, or a stopper, and you just do that and then invert. And just make sure you mix it. That's it. Sometimes what's going to happen is at the end, you're going to have this little mark, and now it's lower. The meniscus is lower than this. When you mix it, you know the solute particles and the solvent particles, they interact. So they interact, and it's almost like they engulf one another, and they actually take up a smaller amount of space. So sometimes you have to add a little bit more water after the fact. That's how you prepare a solution. Are we clear with that? Dilution equation. Yeah, we just did that. All right, percent solutions. Percent solutions are either going to be volume by volume or mass by mass. This one's just like a normal all percent. So it's part that you want over total times 100. This one works really well when you have solvents and solutes that are both liquids. So alcohol, your parents have probably seen this at the grocery store. It has a percent, like a smaller container might have 4.5% ethanol. So 4.5% ethanol means that in 100 milliliters of some solution, which is like some sort of alcoholic beverage, you're going to have 4.5 milliliters ethanol, which is the component that makes people feel weird, over water. I mean, over total solution. So it would be like, it would be like 4.5 milliliters of ethanol per 100 milliliters of solution. So if you did 4.5 divided 100 times 100, you get 4.5%. It's just liquids within liquids because you can't always measure it out very well. For this one right here, can we go and start this problem? Are we okay? Okay. What is the percent volume? So question mark, what's our percent of ethanol in the final solution when you have 85 milliliters of ethanol and it's diluted to a total volume, of 250 milliliters with water. So you're assuming that it says that when it dilutes to the volume of 250, that is our final volume. So that's our total volume. So how would you do this problem? Right, it's really easy. 85 mils of ethanol over over 250 milliliters total solution times 100, and then you get your percent. What if I had told you that I added 250 milliliters of water though instead of to a total? What would you have to do to do this problem?
Add 85.
Yeah, so the denominator has to make sure it's a total solution. So if it wasn't this way, it would have to do 85 plus 250 milliliters first, and then plug that into the denominator. You'll see that on one of your test questions, so I don't want you to mess that up. And then get your percent. That's probably like 12. No, that's more than 12. Thank you. 34% sounds lovely. Okay, and the last one is percent by mass. Same situation, it's just you're doing grams over grams this time, not milliliters over milliliters. So don't forget, again, you have to total the net grams in the bottom. This one's percent by mass. Percent by mass. So if I have a gold nugget that I got gem mining, because I love gem mining. Okay, not gem mining, gold mining. Yeah. What do you call it? Is it gold mining? Washing? Okay. Panning for gold, thank you. So if I found a gold nugget and it was 10 grams total, I put the 10 grams in the bottom, and then they told me that, yeah, lady, you kind of got gypped. There's only like 0.1 grams of gold in there. Where'd I put that? On the top. So 0.1 grams on the top times 100, you get my percent gold and my gold nugget. My fake gold nugget, because it's not actually gold. So it's just simply a grams instead of a volume ratio. All right, and then I want to show you one thing about. The difference between molarity and molality, and then I might let us practice for a minute, or we can practice it in class. I'll get your take on it. So first of all, if I already have a solution and it's full to the brim, got 1,000 milliliters of water. How many grams of water is that? 1,000. Why? Density of water is 1 to 1, right? If I wanted to make a 3 mol solution, my 3 moles equals water or what? So 3 moles of substance over what? But so how many kilograms though? If I specify and say 3 mol, it's per 1 kilogram, right? So I have definitely 3 moles of substance over 1 kilogram of solvent. Solvent is my water, right? So if I want 3 moles of substance, this happens to be rubber substance. Okay, so I'm going to see that as I change from molality, I'm actually going to have an end volume that's a lot larger than whatever I started with, right? But molarity is different. Molarity, I have to say, all right, I want 3 molar. 3 molar means what? 3, what's on the numerator? 3 moles of substance over what? Liters of what? Solution. The whole shebang is a liter. You cannot go over a liter. The molality, it's going to be over whatever the volume I started with. For molarity, the way you have to prepare is you put your stuff in first. So you go, okay, this is going to be 3 molal. So I got 3 moles of substance. And what's my total solution supposed to be? My total substance is going to be 1,000 milliliters, right? So I can see. So here, liquid that never even went in. That means that there's a lot of displacement of fluid with your stuff, with your molds. So there are definitely two different situations or two different calculations because you can see the difference just from this easy demo here. So don't always think that the same molarity, molality definitely have very defined units that are specifically denominators. So if you need to work on that some more, you work on that some more. But let me take it to your lab, and I'll keep loading this other way so you can everybody test it back here. And I have some fancy equipment out for you guys today because I thought you would kind of like it and you get to use some of the technology that you haven't used before. I'll do those more example problems in the class with you. What you're going to do is you're going to create a molarity column. Will you cut the lights for me real fast? Thanks. And the molarity column is going to be in a 10 milliliter graduate center. Going to cut them all. It's hard to see. Yes, there we go. All right, so there's David's awful face there. We've got the density column. You can see the blue, red, yellow, and green. If your job is to, first you have to make that, second you have to accept the challenge of creating another layer. The other layer is of your choice, however you want to make it. You might just want to get it approved by me first. The rules to this game are you have to divide and conquer because this is going to be a process. You've got to decide on your molarity, how many grams do you need, how are you going to prepare it, test conductivity, test temperature difference, create the column. Like 7 or 8 steps, okay? So nobody's going to stand still. No one's going to sit down probably. No one's going to sit and just be off task. So divide and conquer. Everyone needs to be helping with this. You don't want to misuse the equipment because if not, I have to make you count molecules by hand and you don't want to do that either. So you have two pieces of equipment back there. One is a conductivity meter. One is a thermometer probe. They're both connected to the 3 computers I have in the back. So I'm going to have some people rotating around to test their solutions. The volumetric flask I talked about a little bit already, so I'm not going to go over that again. The conductivity meter, don't touch the probe on the end. It's black. It's got this little silver probe out of it. Don't touch it because I don't want it to pick up spoils and stuff off your hands because then it won't measure conductivity very well. The units for conductivity are called microsiemens per second. It goes to micro s per centimeter. So that's what your unit's going to be. Don't worry about what it is. It's just a measure of conductivity. The temperature, I don't have this on the paper, so I want you to make sure you add this to your paper when you get back there. I want you to tell me the delta T of this solution. So at the very beginning, the temperature of water minus the the very beginning water temperature, you're going to just measure and compare that to the end solution temperature. Or just T. So I want to know if this process is endothermic or exothermic. That's mainly what I want to know. And you don't have to do it on all 4 solutions you make. You can do it on 1 and you should be okay. So if you want to start off in the beginning with doing that, that'll be good so you make sure you have enough trials to do it. But other than that, everything is very well described on the paper. I will let you guys choose your groups. You know how this works? I have 4 people in the middle station. Yes, you need paper. Yes, you need goggles. Alright, do you see the lab? I want to do the pre-lab first. It takes about 5 minutes. Okay, when I say 4 at the middle station, I mean 4 total here, 4 total here, 3 everywhere else. So this is the big station that I did. Here's the 3 times. I need one more person back here. I need 3 people here. There's not a soul on this side. 1, 2, 3. 1, 2, 3. I need one of you guys here. So we're going to be
like
It's you deciding on how much you have to do. Okay, calculators.